Hey guys, so in this video I will be teaching you one of the most important part of statistics, which is your hypothesis. Hypothesis. Let me write it down. Testing. Guys, trust me, this is the most important part of statistics, which is widely used in your machine learning or any part of the artificial intelligence or subset of that. And like in this lecture, in this video, we will not be seeing anything about machine learning. Instead, I will be teaching you this topic, which is a topic of statistics, which most of the people find it very difficult. But like what happens actually, this topic is not that difficult. It just some books or other internet providers they make it difficult. So I will try my best, like I always do, by giving a lot of examples. Especially into this, I will be giving a lot of examples to make you understand this simple topic in this video itself. You just have to watch it carefully and make notes of some of the important points, and that's it. You will be learning this topic in this video itself. Like if you go to any YouTube or any other portal, there are like 4 hours to 5 hours of lectures into this, and those are so boring. Trust me, I have been through this topic. When I was learning this, I've been through all this. So before I start with this topic, I must give you one a real life example, like what happened in India in like few years back in 2014. There was a company, like there is a company called as Nestle. There is a company called Nestle. Like mostly all of you have heard of it, and this company was providing, like it's still providing Maggie. Like those who are from India or those who are up to date with current affairs, in 2014 in India government banned Maggie, completely banned Maggie. Like it was completely banned. Now in 2000s, like from 2017 beginning, it started again, but it was banned for almost 3 to 4 years. Why? Because government found the quantity of lead exceeding the permissible limit. So like the permissible limit of lead should be 17.2 ppm, like parts per million. It should be this much, but it was exceeding 1,000 times. So that is very bad, right? I'm just giving you this example, and why I'm giving you this example, that you will be understanding by the mid of this video. All right. So what happened? I'll just give you a short story to make this interesting and not completely boring, because this is a part of statistics. So what happened? There was a food inspector, Sanjay Singh. He checked Nestle, like he went through like normal routine checks. He went to a store and he just like bought a packet of Maggie, and he gave it for some local lab testing, and he found that it was like 1,000 times more, the lead. So what happened? He went further, and like he took some samples from many of the stores, and he, like famous cities in India, and it he collected some samples of Maggie, and provided that samples to the food laboratories to check the lead quantity, and on an average he found that the lead was exceeding 1,000 times, almost 1,000 times. All right. So, and because of that, everything happened, and it got the Maggie, the product Maggie from Nestle got banned. But the thing is, just a simple know-how which I was reading. This can be settled down by paying a penalty of 3 lakhs Indian rupees INR, which is around 4,000 US dollars. But something went wrong and this couldn't happen. So they couldn't pay the penalty of it, and almost 38,000 tons of Maggie from all over the country was collected and destroyed by first crushing it and then mixing it with fuel and burning it in the furnaces in some of the famous cement factories. This is how they destroyed the lead contain so much containing lead in the Maggie. It was so harmful, and people in India were having it from a long time. So it was good. Like they should ban it because there were a lot of health issues which were coming at that time. So now it started again, and they are like making sure the lead is now not even close to the permissible limit. They are keeping it very low. Obviously, they should. So let's come back to our topic. Why I have explained you this? Because like what I want to explain you here is like he cannot just like that guy, the food inspector Sanjay Singh, he cannot collect all the 38,000 tons Maggie just for like at the first. If he found one packet with exceeding lead limit, he cannot, because of that, because of that packet he cannot collect all the 38,000 tons of Maggie packet and give everything for the lead testing, right? That's not feasible and possible. So and he also cannot be sure, like, okay, by taking only one packet of Maggie, he cannot be sure, like, okay, so one packet has this much of exceeding limit, so all the Maggie packets are bad. Like I'm telling you at that time what he was doing. So this both the cases were not possible, right? So what happened at labs, they provided small samples of data from different cities at first. uh, like at first they provided all the samples, like the how it is made, like what is the contents inside the Maggie, and from that they find out some or the other thing. So how they did that, the main point is here how they did that. Like if you want to read this, you can go find it on the internet, you will get the idea of what exactly happened. I'm just giving you a brief about that. But how they did that, how they found that, okay, so it was 10,000 times more. And now, okay, I'm sure like if I have to go and take all the 38,000 tons of Maggie and I have to destroy it, it's a big task, right? It's a loss to the company, like it's a big loss. They did that. The scientists or the engineers who calculated this is that the lead limit was exceeding 1,000 times through hypothesis testing. They did that using the hypothesis testing. All right. So this is what like I want to explain you. So to not to make that uh, this thing boring. All right. So what exactly is hypothesis testing? It is nothing but a claim that we want to test. I hope now you are clear with the definition of hypothesis testing. It is nothing but a claim that we want to test. The claim was the Maggie has this much amount of exceeding lead limit. So why we should do the hypothesis testing? Because it is exceeding the limit. Now we want to do the testing. Okay, I hope this much is clear so far. All right. Now there are two subtopics, I can say there are two parts of hypothesis testing, which is your null hypothesis testing. This is nothing but, if I want to give an like definition of it, it is nothing but currently accepted value for a parameter. So this is the definition: currently accepted value for a parameter. Like if you are in a court, like I'll just explain you this subtopics and then I'll explain you what exactly it is. Another one is your alternate hypothesis testing. These are the two subtopics. Like these combines the hypothesis testing. Without these, it cannot be done, and there are only these two. So let me give you one example here. Null hypothesis testing is always in the favor of whatever is going on, and this is alternate, like just opposite to null. All right. So I will be giving you a lot of examples to just explain what is null and what is alternate. Because in entire internet, if you search, there is no perfect definition which you can easily, like, your concept gets cleared with this. All right. So I'll just give you one example. I'll just erase the screen. You can, if you want to note, like, there is nothing to note, but if you want to note, you can pause the video. All right. Let's say you are in a court. All right. And there is a criminal. Now, there is a criminal, like the now judge has to decide whether this, like, there is a man, he just has to decide whether he's the criminal or not, right? So what null hypo, like, if I want to say, if I said favor, so null hypothesis, it will be always into the favor, like it will say he is innocent, guy is innocent, will always be in favor of it. And alternate, like as the name suggests, alternate, say he is guilty, he did some crime. All right. So what happens here is, the like for if a guy is innocent, then that's okay. But if the guy is guilty, don't you think it, like, if you have seen any movies, like based on any court cases happening inside that, like, if, like, I'm an Indian, I can tell you the Bollywood movies like Pink or Johnny LLBs and all. So there are a lot of evidence they provide to make the guy guilty. They have to provide a lot of valid evidence to provide the guy is guilty, right? So always remember, with guilty, you have to give some evidence. So how we take it, if this guy is found to be innocent, we say, guys, make note of this, how we say, how to say, we always say, if the guy is innocent, we will say, I will reject null hypothesis. I will reject. No, I'm really sorry. I will say I will fail to reject null hypothesis. Like this sentence means I am accepting null hypothesis, right? But we do not say, we never say I am accepting null hypothesis. We will say I am failed. I am failed to reject null hypothesis. Like we cannot reject the null hypothesis here. And similarly, if we have alternate hypothesis, I will say I reject null hypothesis here. Alright, I hope this much is clear. Like if the guy is innocent, I will say I failed to reject null hypothesis. But if this guy is guilty, I will say I reject null hypothesis. Like I am rejecting this case and I am accepting this. I hope this much is clear. That's not that difficult. But we never say I accept null hypothesis. We never say that. Instead, we will always say I fail to reject null hypothesis. Okay, let me give you another example. I'll give you a lot of examples so that null hypothesis and alternate hypothesis cleared. Then I'll move forward. Now let's say in 2017, it is noted that average time to reach a destination A is 40 minutes. In 2018, it is predicted that average time will be 50 minutes for the same thing. So, guys, tell me one thing. If I want to say use the null hypothesis here, what I will say? I am always favored to this, right? I am always favored to the A. So, average time I'll say equals to 40 minutes, and alternate is always be opposite to that. It will be not equal to 40 minutes. So here you are like, you have seen one more thing here is, you can take it as star mark. You can note it as failed to reject null hypothesis is not accepting null hypothesis. Okay, so this is one thing, and another thing is H naught will always be inversely proportional to H1. These are the two things to make note. Alright guys, so this is one example which I have shown. Like, this is the second example. Now let me show you one more thing. There is a small rule here, and the rule is wherever there is a null hypothesis, there can be only three operators: is equals to, smaller than equals to, or greater than equals to. And wherever there is alternate hypothesis, there will be again three operators, which is not equals to, greater than, or less than. In guys, there's a one thing to note: in alternate hypothesis, it cannot be equal to a value. But null hypothesis, like we said, we always favor to the value, so it can be equal to or less than equal to. All right, and since I have said it, they are alternately, like they are inversely proportional. If we have H naught equals to 40, then H1 will always be not equals to 40. If H naught is smaller than equals to 40, then H1 will always be greater than 40. They are they are inversely proportional. They are like mathematically opposite to each other. All right. Now one more thing. Just remember these few terms here. At least, at most, less than, greater than. Just remember these four words. What is this is like, let me give you an example to explain again. Okay, so I'll just give an Amazon example. Let's say Amazon claimed that total evaluation in December 2016 was at least $14 billion. Alright guys, now just pause the video and tell me what will be your guess for null hypothesis and alternate hypothesis. Alright, so now if I'm saying at least, so it means it should be, at least means it should be 14 or greater than 14, right? So it should be 14 or greater than 14. So this will be your null hypothesis. And wherever we are using null hypothesis of greater than, automatically your alternate hypothesis will be less than. I hope you are clear with this example. Now if I just change my at least to, let's say, greater than. So for greater than, alright, so for greater than, h, like it's not saying greater than equals to, it's just saying greater than. So this one, so greater than 14, so it will be obviously less than or equals to 14, since they are mathematically opposite and inversely proportional to each other. I hope you are cleared with h0 and h1 now, right? You guys please make a note of this. Okay, now I will explain you like whether should I accept hypothesis or reject it, like how to do that. So in order to do that, there are various methods. So I'll just erase this and I'll explain you how to do that. Before that, in hypothesis testing, there are two types of it. One is your directional and second one is your non-directional. Okay, so there are two types of hypothesis testing. So directional we will see later. Before with that we will see non-directional, and into that there it is further divided into two methods. Like there are 3-4 methods, but the two methods which are widely used in companies, I'll tell you that. Critical method, or you can say critical value method, and another one is P method. Alright, so again I'll erase the screen to explain critical value method. So let me give you an example again. So guys, in India, cricket is the most popular game. Like 95% or 90, more than 90% of the people watch cricket a lot. And because of that, I'm giving you an example of cricket. Like, uh, let's say I'm playing a cricket match. Okay, so I'm playing a cricket match, and my average score, like like someone asked me what is your average score, so I just calculated my average score of like yesterday I made 80 runs, today I made 60 runs, so average score I can say my average score is 70 runs. All right, but someone asked me or someone checked me, like someone was keeping eye on me from past, let's say, 5 games, and he said like from past 5 games my average score he calculated equals to 20 runs. So what I will say that, like, if I am a normal human being using no machine learning algorithm or no natural statistics, I'll say if it is equals to 20 runs, like if any third person wants to compare, like, is the run whatever I'm saying and whatever the average score is coming. So if like if it's 20 runs, I'll say it's less likely of whatever I said. But if I say, let's say 65 runs, don't you think this is more likely to what I said 70? Like I said 75 runs is my average score, and from past 5 games my average score is 65 runs. So it's more likely of what I said. But if I say 20 runs, it's way far away from 70 runs. So I'll say it's less likely. Now same thing I will explain you how to formulate that using hypothesis testing. Alright, so in hypothesis testing, using hypothesis testing, let's say I have a graph. Alright, this is my graph. Okay, so I said my average score is, I'll take mu, average score is 70 runs. This is my average score. This boundary line is known as upper critical value. This boundary is known as lower critical value. This boundary, I'm talking about this boundary and this boundary. Okay, so what happened? Someone said my average score is 65 runs. So if my average score comes 65, like 65 will be somewhere here. Let's say average is 65 runs. So I will say, like, this I'm very close to it. Like what I'm trying to explain is, if my average score comes between average score comes between LCV and UCV region, like it is between these two. I hope you are getting, like, this is my LCV region and this is my UCV region. But if my average score comes between these two, like somewhere here, I can say, if it is coming here, I can say I reject to, give me 1 second, guys. Okay, right. Sorry, I got confused with my notes. Okay, all right. So, like, yeah, if it lies between the, I'm right. So I will say I failed to reject my null hypothesis. But if my value comes into this region, like this part or this part, I will say I reject null hypothesis. If it comes here, so I will say I fail to reject my null hypothesis because it is coming into my boundary. Like if my number comes here, I will reject the null hypothesis and I will go for the alternate one. Alright, so this is what I was trying to explain here. Okay, so this is nothing but if your value comes here, it will be more likely towards your H1, and if it comes here, it is more likely to be your H0 or your null hypothesis. And how to calculate your LCV and UCV, that I will explain you in some time. Okay, so I hope this much is clear. Now let me give you an example here. There is like, let's say you are going to buy one medicine, and that medicine contains paracetamol. Okay, so like, if I say the optimal quantity of paracetamol in that medicine should be 500 mg, let's say 500 mg. So if my paracetamol content is less, there will be no effect, that I will be explaining you guys. And if it is more, there can be side effects. So what I just explained, you'll understand now. What I'm trying to say is, if it is less, like let's say it is less, there will be no effect. Like paracetamol quantity is less, so the medicine will be of no use. Like basically it is for paracetamol, and there is very less quantity of that, there will be no use. And here, if it is more, the paracetamol content is more than 500 mg, so there will be side effects. Like your body cannot tolerate more than a limited parameter. So this is what I'm trying to explain here. Okay, so this is also known, since there are like two ways of going, there can be two parts. It is also known as two-tailed testing. Okay, and if there is only one part, like I have shown you that Maggie example, lead, like the value of lead can be less, like lead is not that important, it can be less, that no effect in the Maggie. But if it's more, like let's say if it is more, so it is like single tailed or right upper tailed or left upper tailed. Not right upper tailed, it's like right tail test or upper tail test, we call it that. Alright guys, so now let me show you how to calculate your lower critical value and your upper critical value. For that I will be using one example again. Let's say I run an AC store. Okay, so what I saw is that uh, like it is like I'm a wholesale supplier of AC, and I just checked that 350 AC units are supplied per store. I have this information, like 350 AC are sold per store during summers, like this is the season of AC, so it is sold 350 per store. So here my H naught, let's say H naught, or your null hypothesis, I'll say 350 AC. And if I'm saying it is equal to 350 AC, automatically my alternate will be no, it won't be 350 AC, it can be less or more. It will always say that. But the sample data, what I collected, let's say from sample data from 36 different stores, is coming to be let's say 370.6. Like this means like from 36 stores, 370.6 on an average ACs are being sold in summers. So I'll say mu1 equals to 370.6. This is what we have got so far. Now to check whether we should go for 350 value with what I got, or 370.6, which is the mean value of all the stores which I also got. Like which one is correct? If you want to figure out which one is correct and how to do that, I'll tell you that. Before that, there is also one more thing, a simple thing, like if sample mean 370.6 from 36 stores is very far from 350, I will say I will reject my null hypothesis. But if sample mean of 370.6 is very close to 350, I'll say failed to reject my null hypothesis. I hope guys this is clear. This is nothing but what we have seen. If it is like, let's say this is my 350, which what I calculated, and my sample is 370.6, is coming, is like very far. It's very far, somewhere here or somewhere here, very far. We will say I reject my null hypothesis. That's what we have seen in previous page, right? But it is very close, somewhere here, we'll accept it. This region is accepted, this region is alternate one. Okay, guys, are you clear up to this? Or and I hope you are writing each and everything down. All right. So, all right. So I'll tell you one thing here. Now, whenever you are working with your hypothesis testing, one thing you should make note that you should always look for evidence for your alternate. Like I have written in my previous slides, you can go back in this lecture only where I have written your alternate hypothesis H1. In bracket, I have written evidence, giving you an example of the quote, like if you want to prove that guy guilty, you have to give a lot of valid evidences, right? Okay, so just make this in mind, in your mind always. Keep this in your mind. So to solve this AC example, let's say we have some values. Like if you are working on any question or any problem, like we are not into machine learning, guys. Make sure we are not into machine learning. A small concept of machine learning, which in next videos, which you will be seeing, for that this part of statistics is must. So I'm just creating this part of statistics, creating this video just for you. This is not part of the course. All right, I'm just creating that this videos because I can say that you can go and read hypothesis testing by your own, but I don't want to go and go, like I don't want you guys to go and read anything. Like in internet, this topic is, especially this topic, is not well explained. So I want you guys to make it clear, and by giving a lot of examples to keep everything very clear. Still, I would request you to, after this lecture, this video, you should go and read something about hypothesis testing at your own. Then you will be getting a good understanding. If you read after my lecture, if you read anything from your internet, then you will be getting a very good understanding. So to solve a problem of the AC which I have told you, let's say I have some values. Like if you solve any problem in mathematics or statistics, usually we have some values, right? Given, we used to write in school like given this, like given something or something. So so here we have population, standard, deviation. Let's denote it as sigma. We have this value, okay, and in the question we have given, and it is 90. This is nothing but your distribution every year from all the stores, whatever you have distributed the AC thing every year from all the stores. This is the value, and we have our evidence as, let's say, mu x. We have our evidence 370.16. This was our evidence from all the 36 samples and all. So now let's do some calculations. This was given values to us. So there is one thing, guys, like those who are very good with statistics, there is one thing, standard error, which is nothing but your significant distance from a mean what we got from 350. What can be the significant distance, like where our value lies? It is calculated as ST upon square root of samples. SD is nothing but your sigma, which is a population standard deviation, and here sigma we have 90, and n is your number of samples distributed from like how many stores. So we took it as 36 stores, and if you calculate this, you will get a value of 15. So we have a value of 15 here as standard error. Now let's take alpha as 0.05. This is nothing but your like if you are taking 95% of the values to be positive, this like 5% you are still keeping it as, like if the value lies in the 5% area, I'll say I fail to, like I reject my null evidence. So your by default, if nothing is given, alpha is not given, you take it as 5%. Like total is 100%. So if your value comes in your 5% area, you'll say, again, just give me, I'll just draw the diagram and explain. Like if this is the diagram and you say 2.5%, 2.5%, total makes 5%, and this is your 95%. So if you say like the value lies your 5%, if your value lies here and here, so if the values lies here and here, you will say like it is your H1, and if it lies here, it is your H0. So you can, by default, if not alpha is not given, you take it as 5%. But if it is given in the question, you do it accordingly. So if it is 5%, you have to divide the 5% into, if it is a two-tailed, you have to divide it into 2.5, 2.5. If it is single-tailed, you have to divide it into 5% only. I hope you are clear with alpha. Okay. So now another thing we have to draw. Guys, make note of all this because I'm going to erase. So I'll just do one thing here. I'll just erase this and I'll draw one diagram. Okay, so this was my 350 which I calculated, and this is the area where if the value comes, I will reject my H naught, and I'll say this comes into H1 area, H1, and this is my H naught, and here I'll say 350 is okay. I'll say this is your ZC. ZC is nothing but your Z score. Z score or Z score. This is your Z score or Z score. We call it as Z score or Z score. and we have it as 0.9750 of z-score. We already have it that. So we have divided now 5% into 2.5%, 2.5%, which is your 0.025, and same thing here. This will also be 2.5%, which is a 0.025. Guys, please keep pause the video and keep drawing along with me, because if you draw along with me, you will get a good understanding now. So now let's see how to calculate all this. So now our next task is to calculate z score. So to calculate z-score, we have to look. There is a chart which is attached with this video. There is a chart. You have to look into that. This is your chart. This is a chart which looks like. So now how to calculate z-score? We calculate z-score using our value which is given to us, which was what was the value? It was 0.9750. I'll tell you how to calculate that. It is 0.9750. So here in the graph, you have to go towards 0.9750. It is somewhere, it should be yeah, it is here. You can see, right? 0.9750 values here. So what thing you have to do here is, you have to first look the value at the left hand side of it, extreme here, which is your 1.9, and then you have to look at the top value, which is a 0.6. So what next step you have to put is, you have to do 1.9 plus 0.06. This was your value. You have to add them and you will get a value 1.96. This is your value. Okay, so this is the value of z square. This is a z square value. This is how you calculate, and the chart is attached. This is very easy. If you have gone through in your school time, if you are very good with log charts and all, this is how we look, right? All right. So now to calculate your upper critical value, to calculate this, the formula for this is mu plus z score into sigma x. What was our mu? 350. I'm just keeping the values, guys, nothing else. Z square we just calculated, we got from the chart, 1.96 into 15. So if you calculate this, we will get a value somewhere 379.4. We get this value if you calculate each and everything. Similarly, for lower critical value, formula is same. Instead of plus, we use minus. Formula is same. And now if you put all the values here, you will get a value 320.6. So how we check now? If my value, okay, so if my value lies, the value which I got, like from the 36 stores, what was my value from the 36 stores? It was 370, right? Let me just confirm. Yeah, it was 370.6. So my value 370.6 was my value, and if this value lies between UCV and LCV, if this value lies between these values, LCV we just calculated here, and UCV we just calculated here. If this value lies between this, we will say it is somewhere here, and I accept, or we don't say, I'm really sorry, we don't say I accept, I say I fail to reject my null hypothesis. I'll say like this. And if it is not coming between this, like it is coming, some value is like somewhere here or somewhere here, like greater than UCV or less than LCV, we will say I reject null hypothesis. This is how we calculate and we state if I reject or if I fail to reject null hypothesis. Alright guys, so this was the one method which is used in your like this is not used, this is just to explain you in your machine learning, but this is a part of your statistics which I wanted to explain you. Alright, this is the one method. Now there is another method, like there are other methods as well, but these two methods are popularly used in your companies when you are working with your machine learning. Another method is your p-value. This is little easy and not that complicated like your critical value. So let me tell you how to do that. First, let me tell you what p-value is. P-value is nothing but it helps you to measure the strength of your evidence. Whatever the evidence which you are stating, it helps you to measure the strength of that and in support of your null hypothesis. Okay, so basically in short or in your own words, if I want to say, I'll say like it is like a probability of null hypothesis. Like if my probability is high, I'll say I failed to reject the null hypothesis. And if my probability is low, I'll say I reject the null hypothesis. I say I just provide the probability here. So like by default, I have to tell you one thing. By default, you always take the value of alpha as 0.05, which is your 5%. Okay, and like 5% your, which is your 0.25 as your lower and 0.25 as your upper margin. And if it, and so what happens here is like by default, if you take alpha as 0.05, if the value of p comes less than 0.05, guys please make a note, this is the point, this is the important point. Like if you, so you say reject null hypothesis. If the value of p is more than 0.05, you say failed to reject null hypothesis. This is how you calculate thing. Like if the value is not given, you use 0.05. If the value is given, you simply say if p is less than alpha or greater than alpha, like that. All right, make sure you make a note of this right now. Then I'll tell you how to calculate the value of p, but before that make sure you have calculated this. All right, so I'll use the same AC sales example. So there we calculated sigma as I think it was 15. Let me check again. Yeah, so my sigma x was 15 and my mu x was 350 and my x bar, x mean was 370.6. Okay, yeah, right, 370.6. So now how to calculate z-score here? To calculate z-score, there is a formula, sigma x bar minus mu x upon sigma x. If you keep the values here, like 370 minus 16 minus, 370.16, I think it's 6 upon 15, you will be getting 1.34. Now since you already have z-score value, z-score value, we go like in a reverse way in this case. If you have 1.34, we will now split it into 1.3 plus 0.04 And now we will same go ahead and look into the graph which I have, the chart, basically your table which I have provided you. We'll go and look at this 1.3 and 4. So 1.3 is here and your 0.04 is here. Okay, so here we will see the value. What is the value here? 1.3, it is 0.9099. This is our value. So we'll make a note of that value, which is coming to be 0.9099. So now let's calculate the value of P. So P value is calculated as, like, since we are taking as probability of everything is 1. So we'll subtract it from 0.9099, which comes to be 0.0901. This is my P value. Now what I have said, like, if there's one more thing. This is a two-tailed, right? Two-tailed, like there should be two ends. So we do 2 into 0.0901. It will be 0.1802. And if it is one-tailed, you don't have to multiply it by 2. Like, you have to keep the value same. So, but we are now working with the two-tailed problem. Since it was an AC problem, same thing. And my alpha was 0.05. Now just compare the value where P is lying. P is now greater than alpha. You can see that P is greater than alpha, right? This is your alpha P and this is your alpha. P is greater than alpha. So what you will say? Failed to reject your null hypothesis. Okay guys, this is the thing I want to explain. I hope you are clear up to this. If you are, guys, if you have to watch, be it you have to watch this video for 3 times, 4 times, just watch it instead of watching 3 to 4 hours of confusing videos everywhere. Just try to explain things from my video only. I know it can be boring, but trust me guys, if you watch from other videos and all, this will be way more interesting because I have used a lot of examples. Now there's one thing guys, last thing. If your z-square, this comes to be negative, let's say it comes to be negative. If it comes to be negative, you have to again go to the chart, and there is a chart for negative values as well. Okay, so, like, I'll just show you. If you go move up, yeah, you can see the negative values are also here. So same thing you have to follow, there, and you have to get the value here, this value from the graph, and now put the value here, and instead of this minus you have to do plus, and everything will be same. Instead of this minus you have to do plus, everything will be same if the z-square, if this is negative. Otherwise everything will be same as I have told you. Alright guys, I hope your hypothesis testing is now clear inside you. There is one more chart table, like your let me show you. I think I have not downloaded it, but yeah, for your z table there is one more table named as t table that I will also be attaching with this video. And if the question says table entry from or for t table, then you have to look the t table instead of z table. Alright guys, so guys, I have tried to explain you everything by giving a lot of examples. So I hope everything is clear now with this topic, because the next video or the next to next video, some or the other thing from this lecture will be, you'll see, like, it is taken. And if you don't go through this video at least 2 to 3 times, the machine learning concepts after this video will not be very much clear. and that is why I have introduced this 1 hour of session here, which is not the course, which is not in the course. It's like it's the subset of the course. It's like your Python. You have to be like your basics should be clear with your Python, but it's not like I have to start teaching Python videos. I have to put Python videos also here for like 20 hours, so that this course will be of 100 hours. If it goes Python, then NumPy, then Matplotlibs. So it's like that. But still, I have added the statistics topic. This is not a part of machine learning completely, but this is a subset of machine learning. But the what I have explained you today is completely a part of statistics, which people find it very difficult. But I hope you won't find it difficult anymore now. Alright, guys. So keep revising. Make a notes of all these formulas and everything. Just practice 2 3 times. Take and after this, after like taking lecture of this video, after watching this 2 times, I would request you to go to the internet or any books of statistics and go to the hypothesis testing and read it once. Now, if you read it, you won't find anything confusing. All right. So make sure, like, there can be some language issues, like my language at some time or another time, you won't understand some of the other thing. So after like even watching 2 3 times, if you're not getting the things cleared, I would request you to go and just go through this topic once from third party. But before that, I would request you to uh, take this lecture. Alright guys, so I'll just end this video here and let's see in the other video. Thank you so much.